A service entrance rated transfer switch, lacking overcurrent protection, cannot be installed immediately following the meter can. This is due to the essential need for overcurrent protection devices within an electrical system. Their absence poses significant risks to the entire electrical installation. Overcurrent protection, typically provided by circuit breakers or fuses, serves to interrupt the flow of electricity when it exceeds safe levels. This prevents damage to equipment, reduces the risk of fire, and ensures the safety of individuals interacting with the electrical system. Directly connecting a transfer switch without overcurrent protection to the meter can bypasses this critical safety mechanism. The meter can itself generally does not provide overcurrent protection. It is simply an enclosure for the utility meter. Therefore, the entire downstream electrical system becomes vulnerable to fault currents and overloads. In the event of a short circuit or excessive current draw, the lack of overcurrent protection could lead to overheating of conductors, insulation breakdown, and potentially a fire. Electrical codes such as the National Electrical Code, or NEC, and local amendments mandate overcurrent protection at the service entrance. This requirement ensures that the electrical system is adequately protected from potential hazards. The specific requirements for overcurrent protection, including the ampacity rating of the overcurrent devices, vary based on the size and type of the electrical service. Consult the NEC and local electrical codes for detailed guidance. A typical residential electrical service, for example, might have a 200 amp main breaker providing overcurrent protection. This breaker is usually located in the service panel, which is installed after the meter can. In commercial and industrial installations, a service entrance may be significantly larger and require more complex overcurrent protection schemes, but the principle remains the same. Overcurrent protection is always required. There are several reasons why overcurrent protection is essential at the service entrance. Firstly, it protects the service conductors from overloads and short circuits. Service conductors are the wires that run from the utility transformer to the service panel. These conductors are sized to carry the expected load of the building, but they can be damaged by excessive current. Secondly, it protects the electrical equipment within the building. Overloads and short circuits can damage appliances, lighting fixtures, and other electrical devices. Overcurrent protection helps to prevent this damage. Thirdly, it reduces the risk of electrical fires. Overloads and short circuits can cause wires to overheat and ignite nearby materials. Overcurrent protection interrupts the flow of electricity before this can happen. The installation of a transfer switch further complicates the need for overcurrent protection. A transfer switch is used to switch between the utility power and an alternate power source, such as a generator. When the utility power fails, the transfer switch disconnects the building from the utility grid and connects it to the generator. This allows the building to continue to operate during a power outage. However, a transfer switch does not inherently provide overcurrent protection. If the generator is overloaded or if there is a short circuit in the building's electrical system, the transfer switch will not interrupt the flow of electricity. Therefore, it is crucial to ensure that overcurrent protection is in place before the transfer switch. There are several ways to provide overcurrent protection in conjunction with the transfer switch. One option is to install a service entrance rated transfer switch that includes built-in overcurrent protection. These transfer switches have a circuit breaker or fuse built into the switch itself. This provides overcurrent protection for the entire electrical system. Another option is to install a separate overcurrent protection device, such as a circuit breaker or fuse, between the meter can and the transfer switch. This device will protect the service conductors and the transfer switch itself. The specific type and size of overcurrent protection device will depend on the size of the electrical service and the requirements of the local electrical code. It is also important to consider the ampacity rating of the transfer switch. A transfer switch must be rated to handle the maximum current that could flow through it. If the transfer switch is underrated, it could overheat and fail. In addition to the electrical code requirements, there are also practical considerations to keep in mind when installing a transfer switch. It is important to choose a transfer switch that is appropriate for the size and type of electrical system. It is also important to install the transfer switch in a location that is easily accessible and well ventilated. The installation of a transfer switch should always be performed by a qualified electrician. A qualified electrician will be familiar with the electrical code requirements and will be able to install the transfer switch safely and correctly. Improper installation of a transfer switch can create a fire hazard or other safety risks. To summarize, installing a service entrance rated transfer switch directly after the meter can without overcurrent protection is a violation of electrical codes and a safety hazard. Overcurrent protection is essential to protect the electrical system from overloads and short circuits. When installing a transfer switch, ensure that adequate overcurrent protection is in place. Always consult with a qualified electrician to ensure that the installation is performed safely and correctly. Electrical systems are designed with multiple layers of protection. Firstly, the utility company has its own protection devices on the grid to protect its equipment and the distribution system. Secondly, the service entrance overcurrent protection protects the building's electrical system from faults originating outside the building. Thirdly, branch circuit protection protects individual circuits within the building. Each of these layers of protection plays a vital role in ensuring the safety and reliability of the electrical system. Ignoring any of these layers can compromise the entire system. The absence of overcurrent protection can have serious consequences. In the event of a fault, the uncontrolled flow of current can cause significant damage to equipment, create a fire hazard, and even pose a risk of electrical shock. It is therefore imperative to prioritize safety and adhere to all applicable electrical codes and regulations. Remember, electricity is a powerful force that must be handled with care. Always consult with a qualified electrician for any electrical work. This ensures the safety of yourself, your family, and your property. It's also important to note that local jurisdictions may have specific requirements that go beyond the National Electrical Code. These local requirements may be more stringent and must be followed. Check with your local building department or electrical inspector to determine the specific requirements for your area. Furthermore, the type of generator used with the transfer switch can also affect the overcurrent protection requirements. For example, if the generator is capable of producing a fault current that exceeds the rating of the overcurrent protection device, then a different type of overcurrent protection device may be required. A qualified electrician can assess the generator's capabilities and select the appropriate overcurrent protection device. The selection of a proper transfer switch is also critical. Transfer switches come in various types, including manual and automatic. A manual transfer switch requires the user to manually switch between the utility power and the generator power. An automatic transfer switch automatically switches between the two power sources when a power outage occurs. The type of transfer switch that is appropriate for a particular application depends on the user's needs and preferences. In addition to the type of transfer switch, it is also important to consider the size and capacity of the transfer switch. The transfer switch must be sized to handle the maximum current that could flow through it. A transfer switch that is too small could overheat and fail. Finally, it is important to ensure that the transfer switch is properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to protect people and equipment from electrical shock. The grounding system must be installed in accordance with the National Electrical Code and local electrical codes. In summary, the installation of a service entrance rated transfer switch is a complex task that requires careful planning and execution. It is essential to consult with a qualified electrician to ensure that the installation is performed safely and correctly. The electrician will be able to assess the specific requirements of the installation and select the appropriate equipment and wiring. The electrician will also be able to ensure that the installation complies with all applicable electrical codes and regulations. Remember, safety is always the top priority when working with electricity.